Alrighty, guys, how's it going? Good afternoon. My name is Christian Gonzalez.
I'm Ryan Carrion.
I'm Jordan Pantu.
Angelo Verriera.
And this is our presentation over the electric multi-tool, our senior design project. And I'm excited, guys, to share this with you.
Our table of contents consists of the introduction and objective, following up with the project design criteria. And from there, we have the project process design and also the design analysis, and finally, the conclusion.
So this brings us to our introduction and our objectives. So for our project, we needed for our need identification, we needed since you have multiple tools, we wanted to comprise various tools of different industries into a one compact system, which is allowing for multiple consumer options. For this tool, we wanted it to be safe and versatile by accommodating various professions with user-friendly features. With the compact in this design, we also wanted it to be portable and lightweight, and also being robust for different work environments.
So in the blue collar industry, there is a need for a portable and lightweight tool that is able to be used in any kind of condition or any kind of condition with an inside or outside. So our electric multi-tool kit is the answer for that problem. It is to be used within a range between green and like seasoned workers in the blue collar field. And this device consists of an electric scissor jack, an electric wrench, and a manual conduit bender. And also with our design, we're hoping to implement more tools that could be changed and swapped, kind of like you order as you go. Whatever tools you want within the kit, it will be there. Our goals for our senior design project were to design a cost-effective system for maintenance and emergencies, as well as stay within our given standards, constraints, and code books that we had assigned and we had found, as well as design a very user-friendly interface that can be used within any skill range.
So here you're going to see our objectives. One of our objectives is to integrate our 3 tools all into one compact. This includes the scissor jack, the electric wrench, and the conduit bender. Second one is that it must be versatile to multiple environments, whether it's raining, snowing, freezing. My third one is that we wanted it to work 12 volts, so that way you could plug it in if you're on the side of the road or if you don't have access to power, which may be the case for some workers. With the scissor jack function, we would like to at least provide a foot of clearance with our electric wrench. We would like to do 200 foot-pounds of torque, and the tool should be able to also bend a conduit to multiple desired angles.
So kind of going into the next project, those are our goals and our objectives for this project. So now it's like, okay, how are we going to achieve these goals? So kind of here in this section, we're going to go over those specific things. So kind of going to this is a design class. So I kind of want to show you guys like the method that that we've been learning our entire, college career. First we want to define the problem, gather some information, get some voice of the customers, see what's in the market, and then generate some concepts and ideas, some very early conceptual designs. After that, we evaluate these ideas, like how applicable, is this achievable, is this realistic? Then after that, we actually go into like actually designing it. So doing project architectures and configuration of design, the parametric design. So that's actually once you find your needs and your identifications, like, okay, how can we actually make this realistic and become a project?
So to go over the project functions, the main function is to lift at least 5,000 pounds efficiently with the given parameters. It'll do this through a jack system and a motor system. Aside from those, there's 2 other tools stated, like a pipe bender and a electric lug nut remover. This tool is portable, so you're able to use these functions at any location. And it's usable in different crafts, from the automotive, electrician, and plumbing. For the project constraints, first one being load capacity, it should be able to lift at least 2,500 pounds with a factor safety of 2. The whole system should be compatible with a 12-volt power supply to power it up. When using these functions, they should be reliable, so you should be able to use these in any harsh condition, water, mud, dirt. The jack, the pipe bender, and the electric tool should follow the standards and codes books. There's 3 of them. And for the last 2, the size and weight, it should be portable, small size, and lightweight to be able to move at any location.
So now going to the project design process. So kind of here, when we're making these ideas, kind of going back to when we went to the design process, we use the decision matrix to actually help us pick our things. So I'll be covering over the lifting jack. So in there, you can see we have 5 different methods: the trolley jack, the hydraulic jack, the scissor jack, and the screw jack, and the pneumatic jack. We kind of went through those, and as a team, we all discussed and met and like, okay, what is the best application? We want something that's portable, quick, and easy to use. So through here, we went through the criteria. Our criteria was a system design. How could this be applicable to our actual need and necessity? The clearance for the scissor jack, that's the biggest thing. We want to make sure we get that foot of clearance. Safety is always a priority. Weight capacity, since we want to make it lightweight, we want to make sure it's we design something that is, you know, not going to be super heavy. And then ease of use as well. And price is always a big factor. So that's kind of why we picked the scissor jack. It was the best one overall for the lifting jack.
Yes, and for the electric wrench, we came to the decision that it would be the best one, due to its accessibility, its portability, the overall design of it, the safety of it and the weight, and just everything about it makes sense compared to pneumatic and hydraulic, because those would weigh much more.
So for the conduit bender, we decided to go with the manual conduit bender simply due to the cost. With the mechanical, the electrical, the hydraulic, and the PVC bender, they weren't really fitting our constraints that we needed. We needed something that was portable. The mechanical, the electrical, and the hydraulic were very big and bulky, needed a lot of work to be done for design purposes. So in that case, we went to the hand bender, which is very, very simple, which is one of the reasons why we had chose it. And of course, again, cost effective.
Yeah, so I'll be going over the project design of the model. So this is kind of our design process of the scissor jack. So on the left figure, you can see our conceptual model. This is what we did, you know, when we were starting our brainstorming. We knew we wanted to do scissor jack, so we did some research. You know, you have 4 beams, you have the screw jack in there that actually lifts the vehicle, and we know it must be withstand 5,000 pounds. That is due to the factor of safety of 2 with the 2,500. So we were thinking having a clearance of 12 to 16 inches, a overall length of 12 inches, and a width of 4 to 6 inches. And we're thinking materials wise, ASME 836 steel for the linkages and the bars. And for the worm gear, we're thinking a cast iron. And then Jordan's going to cover a bit of our first initial model.
So for our initial model, it was our first design was a 6-bar linkage. We decided like it was kind of over engineered. One, because we had 9-inch arms, and then because like if one of these arms was to fail, then you'd have to take that arm off, which is through a screw, and if those screws are sheared off, then you ain't gonna get it off. So you have to replace your whole jack. So this was a bit over engineered. So for this clearance, we had from a collapsible of 4 inches to a maximum clearance height of 18 inches. This allowed, but this also had a length of a total of 21 inches when fully collapsed. And our total width came out to about 4.5 inches. And then
Yeah. So kind of going to the final model. As you can tell, that first model was kind of big, and it was a 6-bar linkage. We over-engineered it. It would take the stress pretty well and pretty comprised, but overall it was heavy and it was like too much for us. And I really didn't like the way that the actual mounting point was on it. I think that's unsafe. That's an old design. The new design, we want to simplify it. We made a 4-bar linkage. We realized that, hey, we actually don't need a linkage. We can just put a bar that connects to the gear, to the screw, and it'll work just as fine. So that's how you can see we did a 4-bar linkage. It actually weighs only around 15 pounds, and it has 7-inch arms and has a clearance of 13.5 feet. When it's totally collapsed, it's 6.5 inches, and it can rise up to, I want to say about 16, I want to say. And then, yeah, it's length as well as 18 inches. The only reason the length is so big is because of the screw on it. The actual frame of the component of the scissor jack is only about, they're both about like 11 inches. So that's really just the screw length. And then the width is 3.5, which is, I like that design. And then we use pins for this instead of actual screws as well.
So here for the product design is for the electric wrench. So on the left is the conceptual model. It was just to get an idea of like, okay, this is how we're gonna have gears. This is how we're gonna have it set up. So with the final gear, this is like where the shaft would come out, and we would attach like the anvil to where the socket would come. So we had to set some parameters with our motor, an input speed of about 8,000 RPMs. The output, it should be about 7,000. Once there's like actually a load being applied to it. We talked with Dr. Lum to get a gear ratio, because it was something that we had to set as initial parameter. So we went with 20:1, the output 200 foot-pounds, typically, because like if you want to use this for like removing lug nuts, it's like usually between like 80 to 140. And then to the right is just showing the gears, and it's all the works.
So for this is our conduit bender. Our initial concept model was a little bit more basic than our next initial model. So the goal for this, we're gonna have it attached to the side of our housing because it just makes sense, along with the shoes and the lever arm are gonna go ahead and be detachable via pins. So our tube diameters we're initially trying to go for were for 1/2 inch and full inch diameters for our conduits. And the length of the lever was about 6 inches. Our materials that we actually carried over into the initial model was the pins needed to be AISI 1020 cold rolled steel. Our aluminum alloy for the shoes and the lever arm were going to be aluminum alloy 2024. With the initial models you can see here on the right hand side is going to be 10 inches in length, 11 inches wide, and about 9 pounds for the entire shoes and the lever arm, not including the frame. So our next thing for the conduit bender was we needed to have it we need to have it different. So we decided to go with the quick release pens to remove the shoes, which are the blue and the orange that are right there stated. And we wanted to change them out from a 1/4 inch to 3/8 inch to a 1/2 inch. So it's also good for portability and storage as well.
This right here is our project design final system model. Well, as you can see, to the left is our conduit bender, and to the right is the scissor jack attached to it. And also within this model is the gears, the motors, and the wiring system within it to make everything work out. And also for our electric wrench, it's going to be attached to the housing. That way it gives it a better charging capacity and also a better workflow and everything.
So this is our tentative BOM list so far. So far we have our cost for the motors, the jack screws, a lot of the gears, the aluminum is going to be used for the housing and for, of course, like the shoes and things like that. So with all this total cost, we came out to about $373. It's very, very tentative. It is very able to change. So just take this with a grain of salt, please.
So this is our wiring diagram. We started off from a power source that runs power to your fuses, and then your fuses to your switches, and then power to the motor and the electric lug nut remover.
So design analysis, we're gonna take I'll give a quick break. I just want to elaborate a bit more on the final design system. So this is our first initial model. So the conduit bender, we really were given a really short time frame for that, as well as the gear the electric wrench. So this is a very tentative model. This is the idea, but I kind of want to elaborate a bit more that. So the idea is that this jack would be attached here, and there would be a hole connected to a motor in there that actually powers the jack. So the idea is like you would get this tool connected to your vehicle to the 12-volt battery source, and then you would have it, place it under the vehicle, and you'll be able to lift it. And the conduit bender, the idea is like you can just have it there, put it in the back of your truck, and use it to bend conduit to the needs you would want. And then kind of what Jafet was talking about, the electric lug nut, it would have a connector to the actual system. I would connect to the power source there, and you can remove the lug nuts there. So that's the idea that we're going for. This is our first initial model. It's not a final system model. This is just what we got to right now. But of course, we're going to keep optimizing and giving it better iterations as we go. So going to the design analysis. So here's the stress analysis over our scissor jack. For the stress, we weren't really too worried about it. I designed it to be a 1/4 inch, which is really thick for jacks. I just want to make sure, hey, play it safe. You're trusting this thing to carry, to lift a vehicle on top of you. To lift a vehicle on top of you, you should, you want to make sure it's safe and reliable. You don't want to, test it too much. So the max stress acting on it was a 410 PSI. You convert that, it works out pretty well. For the displacement, that's what I was more worried about, just to see the displacement of how this jack would be, because, you could be under a jack for, 10 minutes, 5 minutes to 30 minutes. We want to make sure this thing's reliable and, can actually hold it. We did have some high stress at the top, but it was only max displacement of like a 1/20th of an inch. So to me, it looks really good. I do have the math to back it up if you guys are curious, but you can see in the displacement as well, the torque at the end of on the side looking towards us is higher just because that's where the torque is gonna be. And then
Is the video play? So this is just a video demonstration of the gears rotating with the motor.
I don't elaborate how it is.
So right here is just a video showing the conduit bender in action, what it would look like. Our goal is to have it bend from 0 to 180 degrees, kind of like a protractor. And we're going to go ahead and have labels of the angles that are needed, that are desired on there as well.
So in conclusion, the team's collaborative effort to achieve the goal despite our project timeline architecture. So kind of like I was saying earlier, this is a very new system design. We had quite a bit in our timeline. Our project statement really changed. It was going back and forth. It went from one side to another side. So we were just kind of in that phase. We're like, okay, we're designing this, and then it would be switched to another one. So it was just a lot of going back and forth. Of course, as an early iteration of our multi-tool, the goal is to add more tools and systems and make it more applicable towards different applications. So like if an electrician needs it, the conduit bender would be a good application. But at the end of the day, we also want to make it available with more tools and stuff. So that's the idea of it. It's kind of where we're at.
And for our next steps is to finish the system final model, update our boom list. From there, start the development of the prototypes for Multitool kit, and also optimize and improve upon our design iteration.
Some acknowledgements.
So we would like to thank the university for the help and support through our education in mechanical engineering. We'd also like to thank our professor, Mr. Grady and Sensi, for his support for our project. And we'd also like to thank Professor Dr. Alam for his mentorship and guidance into our project.
Yeah, and then we really want to thank the college for just giving us the opportunity to hear. We start here as freshmen, and just going to this point, our senior design. We're really excited and we're grateful to be here. 2 minutes. Yeah. And thank you. Any comments or questions? I know that was kind of quick. But I'm ready.
Let's give him a hand. Start out from our judges first. Go for it.
Yes.
I have a question. I want to know what kind of considerations y'all, like from the 1,000-foot view of the people who would be using the tool.
Mhm.
How did you choose which collection of attributes that it would have and who that would be useful to?
So we just decided, again, this is a very tentative model, but the goal was to make it to where we have different tools for different applications. So it's kind of like ordering something. You wanted a different color, you wanted to be this length. So the goal is to if you like my colleague here was saying, if you're an electrician, you're really going to want the conduit bender. Like that's one you're really going to need, and possibly even the jack for any kind of purposes. So that was really our thought process of it. Because sometimes people are in very confined and tight spaces, such as welders and again electricians as well. People in the automotive industry. That was our thought process of where we could take this project to.
Yeah, and then I'm just gonna add some context to that. When we started this project, our problem statement was more towards the automotive, like emergency roadside tool idea. But then we tried to design. Well, we were in the idea of creating an impact tool, and it's not as easy as it looks. It's not as easy at all. So after that consideration and meeting with our advisors, they're like, "Hey, let's take a different approach." And that's where kind of like the indecisiveness really went. But the idea was that it was going to be a tool that you could use that in any case, any situation, it's all in one tool that can help with your situation. So right now, kind of like your question, this would be really good for electrician or ranch handler, who's working on the ranch who might not have access to all these tools. They can have it in one tool kit.
Just a quick follow on that.
Yes.
If you talk to anybody who might be using this, well, talk to electrician, welder.
I mean, I did talk with my grandpa. My grandpa was a known welder, and I had asked him about it out of pure curiosity sometimes, and he had mentioned that a lot of the times you are in very confined spaces where you just there's not a lot of room to be anywhere. So, you're inside of a vessel or you're underneath a heat exchanger, things like that. It's just very weird and just very weird spaces, and you can't really have the big multiple tools that are just their own size and their own weight. Instead, we would just the one small package would just be better.
The idea for me is I reached out to my family. My family does a lot of blue collar jobs. So we do a lot. I have an uncle who does a lot of work at the King Ranch. I have a cousin who's a welder for the King Ranch. He tells me I just get into the trucks. They have so many different tools and stuff. And I'm I get in there. I'm like, you haven't used that tool in 3 months. Why do you still have it in there? It's like, well, I just need it. You never know when you need these applications, So to my idea, I was like, hey, what do you think about a tool that I was asking him, list me some objects that you would be used as a welder. Hey, that would be good to have in one kit, not just to have individual parts. And then think about it. Tools are expensive. So maybe we can make a cost analysis, make it cost effective and in one system. That's the idea we're going towards. Yes.
So
You guys mentioned your space requirements.
Mhm.
It seems to me like looking at this, at least your control box is significantly larger than a traditional size jack. The pipe conduit bender, when attached to it, isn't really gonna be able to be utilized as a pipe bender depending on where it is. What advantage do you see in having all these tools combined into a single unit versus using the 3 individual tools independently?
Okay, so so for this model, it was a very early iteration, the conduit bender, we finished that 2 days ago. But the idea is that black part right there, it's actually supposed to be part of the frame, so it's supposed to be connected there. The idea is like, this is supposed to be a lightweight tool, you can carry it, connect it where you need. For the conduit bender, you won't actually have to actually connect it, so you could just lift it, put it in the back of your truck, and use the conduit bender like that.
Essentially just at different leverages wherever available. I understand, looking at it now, the way you described it, it does seem kind of weird the way it is arranged.
And very boxy.
But again, this is also very tentative, so we will definitely take that into consideration, so.
The jack, even with a flat top.
Mhm.
But if you're gonna use a jack, I'm hoping maybe you have to go on a tire.
Mhm.
When you start going up, the vehicle starts in an incline.
Mhm.
So why did you choose the flat top versus the one with the grooves? That would,
Yeah,
I
so
know you said it was a safety factor, but I'm trying to figure
you're
out.
trying to understand that thought
Yeah.
process. Yeah, so the idea too on the jack as well, you see how this one has a cup holder. I understand where you said, hey, there's a leverage of cup there, right? That's
Yeah.
yeah. The idea is with this one, I didn't have enough time, but I was supposed to add some crickets to it, so it would actually hold it as well. So
Oh,
like it
okay.
has some indentions in there. It was supposed to be flat, but yeah.
Basically, the plate is a clinch to hold on to.
Yeah. And then when you put a jack, you should usually put on the pinch point on it, and that's the idea you're going to it. But that's a very good point.
In, why the safety factor of 2?
Safety factor too. So the design was the intention of the scissor jack is to lift up side of the vehicle, like if you get a flat in that type of emergency situation. We took the average weight of vehicles and it was 2,500, but a factor safety of 2, so it's 5,000 pounds. We designed it to hold 5,000 pounds for that reason. So it'd be able safely, comfortably lift up to 5,000 pounds, but we just want you to carry the quarter of the vehicle.
So essentially just adding on to that, basically it's like, take a sedan weighs different than a pickup truck.
Mhm.
So the 2,500 average pound of all the vehicles would be for a sedan. But in case we needed to lift the point of a pickup truck, we're able to lift that point of the pickup truck.
As a consumer, what would be the advantage to purchase your jack versus a jack that came with my vehicle that looks very similar?
So the advantage to that would be just, I guess just our interface would be a lot better, and also it would be electric. So the jack that you get in like the vehicle, a little bottle jack, you have to use that manually. And again, an early design process, we're aiming towards it being like the ultimate emergency roadside kit. So it could be used within, like, if you're on the side of the road, you're you're just in a weird spot, it's raining, it's snowing. Just instead of being out there, just cranking it or whatever you need to do with the jack, it's electric. So you just plug it in to the 12-volt car. That's why we had the 12-volt car power source.
So as a consumer that uses these things, right?
Mhm.
Like I carry an impact for each earth main with a socket for the jack.
Yes, sir.
So what's the incentive to purchase this tool versus tools I already have or things that already came with you?
Essentially just that it's all together in one instead of purchasing them separately is essentially
You're like $300 and something
Yeah.
on this, where like if you're cheap like me, just go to Harbor Freight, I can get it
Yeah.
for like $20 and
Yeah.
buy the Wheeler Bauer for like 100 and I can. Yeah.
Yeah, we're still optimizing it, but we're really early development. But the idea is that this frame is gonna get smaller designed, and then we're gonna have features that we want. So we're also thinking, we're thinking this at the beginning of the design process, have a wireless key. So you could just connect this, put in there, you can get in your car, have it lift up, safely switch. Like we're gonna add more accommodations to make it worth it. And also we're aiming it towards all consumers. So think about it, you're very young, you know how to use tools, but what about the older generation who might not be as,
for the people that aren't really knowledgeable how to use a jack or anything like that. That's also what we're aiming towards. For people like that, it's just easy just to press a button, put it underneath the truck, press a button, other than just like go and take it and or just like you said, use an impact just to do it.
and then the younger generation too. My little brother doesn't know how to use tools and stuff, and that's just like, come on. But towards them, towards that.
Quick question, are you guys first semester team or second semester team?
Second semester.
Because you kept talking about how you're gonna do more and you haven't had time to do this stuff.
Mhm.
Anyway, go ahead. Second semester team, okay. The means have been working on it for about a year now.
Time that we have, Dr. Peter.
We got about 2 more minutes for questions.
I have a question.
Yes, sir.
Go back to your rotary. Could you describe the gear train and why do you need 8,000 RPM to take off a lug nut?
That's the motor. It has the output of 8,000 RPMs. So whenever I was looking for motors, very similar motors were used, like within that range between 5 to 10,000 RPMs. Whenever I talked to Alam, he said to try and use like something similar in that range. So it's not really about the RPMs, it's more about the torque output. And so using that motor, I was able to use those gears and to get the like exceed 205 pounds.
It's a concept right there. Do you have any analysis?
No.
No analysis. Oh, okay, so why?
So we were going between tools, so we're between the impact, we had went to a ratchet and then we went to the electric wrench. So just unfortunately due to time constraints, I wasn't able to do an FE analysis on it, unfortunately.
Let's give him a hand.